Hello everyone, this is Anil Kumar, Assistant Professor in Civil Engineering Department at Annamacharya University. In the previous lectures, we have discussed how to draw influence lines for the reactions for the condition of a simply supported beam carrying a unit load. Here in this lecture, we will see how to draw influence lines for the shear force and bending moment as well for the same condition of simply supported beam. Shear force, or else we can also write influence lines for shear force. For this condition, we will assume a simply supported beam. Simply supported beam carrying a unit load of 1 kilonewton and having beam length about L units, and let it be these points as A and B, and this point B as E, capital E, and the distance from that point to point A, let it be C. Now the point occurs. Before going to draw the shear, draw the influence lines for shear force, first we will draw influence line for the reactions. First we will draw influence line for reaction RA. This is RB. Okay, what is the influence? What is the variation for the influence line for reaction RA? We have seen in the previous lecture, that is linearly varying like this. This is the intensity of 1. This is all a positive zone. Okay. Now we need to find out. Now we can point out this unit load here. Okay. Coming to what is the influence? What is the intensity? What is the intensity here? Intensity of this influence line at this point. For RA, that will be L minus X by L. This is the intensity of influence line at under the point load. But here in this case, we have the distance of C. If the distance from point A to point E is X, then we will get influence line as like this, L minus X by L. But here in this case, we have the distance of C from point A to E. Now, what is the intensity will be here? L minus C by L. Okay. Now to draw the influence line for shear force, there are two conditions are arriving here. One is when the section is when the load is just right to the section. When the load is just right to the section, and another condition is when the load is just left to the section. These are the two conditions. First we will see the first condition, when the load is just right side to the section. Here in this case, SF is simply equals to RA. What is RA? Here we have got L minus C by L. This is the shear. This is the case when the load is just right side. Coming to second case, the load is just left side. Then the shear force will be simply RA minus 1. Why? Because it is having a unit load. RA minus 1. What is RA? L minus C by L minus 1. We can write, or we can take LCM as L minus C minus L. These will get cancelled. Finally, SF is equals to minus C by L. Here The shear force when the load is just right to the section will be 1 minus C by L. When the load is just left to the section, then the SF will be minus C by L. Now we will mention, we will show these intensity on the diagram. Here is point 1 with the distance of C, A and B, the length L. Okay. Yes. So when what is the reaction? We'll see. See, first we will show left, just right side of the condition. What is it? 1 minus C by L, that is positive. Okay, positive from exactly at this point. This is A and B. Positive zone means in the influence lines topic, always the negative zone is representing at the top of the beam and positive zone is representing at the bottom of the beam. Likewise here L minus C by L will be shown at the bottom of the beam. Next one is at left of the section, SF is equals to minus C by L. That means minus C by L means we need to show top of the beam minus C by L, and then join this point to this point and then this point to this here. These are all negative zone. This is negative zone and this is a positive zone. The intensity here it is C by L. I am not representing negative here, minus here. Why? Because as we are representing this as negative zone. Likewise here also L minus C by L. This is the intensity. This is called IL for shear force. This is the influence. This is how the influence lines will look like this. Next condition. Influence line for bending moment. Influence line for bending moment. Okay. Now the same condition we can assume. What is it? A simply supported beam having length L, and it is subjected to a unit load at a distance of C from the left end, that is from point A. This is B, and let this point be E. Okay. Okay, here also in this case also we need to consider when the load is just right to the section and when the load is just left to the section. Okay, first case, load is just right to the section. Bending moment is equals to, as we have seen, shear force is equals to just simply RA. Likewise here bending moment is equals to this RA multiplied by the distance up to the section. What is the distance up to the section from RA? It is C. So we can write RA into C. What is RA we have got earlier? L minus C by L multiplied by C. This is the bending moment This is the bending moment when the load is just right side to the section. Next condition, load is just left side. Here in this case we can consider the load is just left side to the section, and that too with a distance of x meters we can say. Say for example, here I will draw. This is B, this is A and RA, RB. When the load is, this is condition B, when the load is just left side of the section, and that too with the distance of x from point A. Let it be like this here. This is 1 kilonewton and a distance of x, at a distance of x here. So what is the bending moment here? Bending moment is equals to here. What is bending moment here now? RA into x minus this portion we need to mention. What is this portion? What will be? From here to here it is C, then from here to here that is C minus x. How can we write C minus x? First we have written RA into C, sorry, not x. RA into C. That means here from here to E is C distance C, RA into C, and then unit load. What what distance it is? Unit load is there 1 kilonewton multiplied by what is this distance? Total C minus x we have written, or else we can also mention here 1 into C minus x, RA into C and 1 into C minus x. That's why I have mentioned here minus 1 into C minus x. Then what is RA in this condition? Earlier with the load at a distance of C, then the RA will be L minus C by L. But here the load is at a distance of x meters from A. That's why we can write L minus x by L multiplied by C minus C plus x. Why? Because it will be minus into minus plus. We can write minus C plus x. Oh, we will move on to next page. L minus x. Bending moment is equals to L minus x by L into C minus x, minus C plus x. Now L minus C, L into C by L minus x into C by L minus C plus x. Here L get cancelled and C minus x into C by L minus C plus x. This C will also get cancelled and we will write this x at front, x minus x into C by L, and by taking x by L as common, x by L, here we will get, what will get? L. Here in this term the C will be remaining. Bending moment at section x is equals to x by L into L minus C. Now we will show these intensities in the bending moment diagram. Let it be A and B. See what is the intensity at we will show at this is section E and this is the section X. Okay, what is the intensity at section E? That is L minus C by L, L minus C by L multiplied by C. And what is the intensity at X? We will show next. First join these things from here to here, and then from here to point A the bending moment will get 0. Okay, and then What is the intensity of bending moment at section X? Here what it will be? What it is? X by L into L minus C. This is the bending moment at section X, and this is the bending moment at section E. This is influence line for bending moment. As what we have discussed in this class, we have discussed about how to draw influence line for shear force for the condition of simply supported beam carrying a unit load at a distance of C, and then later we have discussed how to draw influence line for bending moment for the same condition of simply supported beam carrying a unit load at a distance of C. In the next classes, we will discuss about how to draw influence line for the simply supported beam carrying a UDL, and also we will deal about a simply supported beam carrying 2-point loads and also several point loads, that is nothing but 4 loads or 5 loads.